Let's solve the question count Subarrays. In the question, you'll be given with a permutation P of length n, and for each I, find the number of subarrays of P. Like P is the permutation with some I. Like for each ith index, you have to find how many number of subarrays of P are there with that I. And the permutation of length n consists of all the distant integers from 1 to n, which are exactly ones present in the permutation. So let's make it more clear. Question में permutation p given होगा of length n, and we have to return an answer of length n. So that इसका जो भी indexes होगा, that is one based indexing, वो contain करेगा, that is number of subarrays with some I, if I am standing at the ith index with some I, and that subarray belongs to P. That is given in the question, which is a permutation. Now, how could we find that? If we are standing on some element of P, let's say I'm standing at the third index, so can I know that how many subarrays that this 3, the index 3, let's say it have x. Now can I know like how many subarray sums that this x can create, like this with this previous elements, like x can merge with 2, can merge with, this is the second index element, I'm standing at the third index, so 3 2 or 3 2 1, like the third index, second index as well as the first index, or 3 alone. So these are the 3 subarrays possible with the element at the third index with this previous elements. So if this sum exceeds some value, let's say 2 1 is greater than n, the sum for the element at index 2 and the element at index 1 is greater than n, then there is no need to check for 3. If it is already greater than n, then why 3 would check with 2 1? Like let's say 2 has a subarray sum array, let's say, which is containing the sums of subarrays possible from the second index with previous elements with less than n sum. So 2 will contain only 2, because 2 plus 1 is greater than n. The element at the second index and the element at the first index is already greater than n, so this will not be included in this array. So if 3 will search for, then what, the second index already have an array with its sums of subarray, so that is containing only the element 2. So 3 will check with itself and 3 will check with the element at the 2. So if this thing is less than equals to n, then we can take it. Why? Because we are returning our answer of length n, so we need the subarray sum from 1 to n only. So if it is greater than n, so there is no need of those subarray sums. So the important thing is over here, we can use previous elements possible subarray sum array, sum array. So this thing can be used for each and every element. Now you would be thinking that if we are checking for all these sub arrays, then what the time limit would be for this. Now let's say I'm standing at the 0 1 based indexing. If we are following 3 4, then this 4, how many sub arrays this can 4 with the previous elements, like 4 can combine with 3, 4 3 2 we can have, 4 3 2 1 we can have, as well as 4 we can have alone. So these are 1 2 3 4, the index in which I am standing. If I am standing at ith index, then the of subarrays it can form is I only. As I'm standing at the fourth index, and the number of subarrays it is forming is also 4. So what I need is, if I can eliminate some subarrays, like if I'm taking the worst case and I'm standing at 1, and there is 2, 3, 4, 5, then how many subarrays this 1 can form with sum less than equals to n? Because if sum exceeds n, then there is no mean of those subarrays. I don't want that. I want only the subarrays from 1 to n, which I have to return. So how many subarrays this 1 can form? If it is 6, 7, up to 10 to the power 9, like 10 to the power 5, it's this many numbers I can have. So how many elements this 1 can have? So that is, we can say it's a natural number sum. So it's, let's say it can form a subarray up to xth element. So it would be x terms. So x into x plus 1 divided by 2 must be less than of equals to n, that the sum that 1 is forming with all the elements like 1, 2, 3, 4, 5, 6, so on and so forth, should be less than equals to n, because we want the subarray sum should be less than equals to n. So if we are like rough it out, it would be like x square less than equals to n, and x should be less than the worst case n would be 10 to the power 5. So it would be 10 root 10 to the power 5. So x should be lesser than 10 to the power 3, we can say. If you roughly calculate this, it would be that x would be less than 10 to the power 3. So in the worst case, each element can have a subarray of less than equals to 10 to the power 3. It will be much lesser, but roughly we have calculated. So if we are traversing for each and every element of the permutation P, like how many subarray sums that this particular ith index element can have. So the previous element subarray will contain less than 10 to the power 3 elements. So if the length for this P is 10 to the power 5, so the overall time complexity will be 10 to the power 5 into 10 to the power 3. It will be lesser than this. So it will be lesser than 10 to the power 8 for sure. So we can solve using this algorithm. So using the previous index subarray that the element is forming. So that's it. Let me show the code for a better explanation. What I've done in the code is, first I've taken input integer, and that is the length of the permutation. Then I have taken the array for the permutation, and answer will be storing the number of subarray with sum. Like answer of I will be representing the number of subarrays with sum I. So if we're considering the first element will be forming a subarray with itself only, that is a one length subarray, that is error 0 itself. Now the sum that error 0 will be contributing to error 0 itself. So that's why I am incrementing that position in the answer, because answer of I is storing is the number of subarray with sum I. So sum over here is error 0, that's why I am incrementing by 1. After that, A will be containing the number of subarrays that this element at the 0th index is contributing. It is contributing a sum of error 0 only, because it cannot form subarray with the previous elements, because it's the first element only. So the subarray sum it can have is itself only. Now I'll be traversing from the first index up to the end. Now current will be storing the subarrays, the sum of the subarrays that this ith element will be having. Now, the element at the ith index will be forming one subarray with itself, that is one length subarray. So that's why I pushed that sum error I in the current and contributed that error I into the answer. After that, I have traversed through each and every element. This element is representing the subarray sum of previous element. So I can include the current element in the previous element to form the subarrays Also, like this is a sum that the previous element. I'm standing at I. So what are the subarrays that I minus one element was having? So that is element those subarray sums. So if the current element plus the previous element's subarray sum, if it is less than equals to n, then it can be of use because we want a subarray from 1 to n only. So if it is less than equals to n, then I'll push that into the current and I'll contribute that sum into the answer also because the current element and the previous element subarray sum. So that is plus element. So that's why I've done. After that, I have replaced a with current. Now, as I will get incremented, like I is currently 1, then it will get incremented to 2. So we will want the sub array sums, which was I equals to 1 was having, that the element at the first index was having, that is current. So I am making the current as previous now, as I will get incremented. So we'll be checking for the next element. After that, I have printed the answer. So that's it. I hope you like it. Thank you for watching.